So I would like to talk about my project, what I wanted to create for 210 embedded. And so I wanted to create this smart traffic light. So when we're generally talking about the traffic lights, those are set up on a particular direction. So whenever a lane is quite filled, it doesn't see that, and the lanes which are empty at point, that particular period of time, the it could have like the lane which is completely filled could have the signals red for them, and the lane which is completely empty could have the signal green for them. So that's not sufficient because it creates a delay for people in with in quite emergency, and sometimes it could be frustrating while looking at the other lanes where the traffic is seems to be zero to none. Um, Only about two or three vehicles over there, and the other lane is completely filled. So to make it more sufficient and to make it more efficient for people, I wanted to propose this smart traffic light system. So let's look into this. So I would be using Raspberry Pi in order to create the GUI and do the few analysis, even though that isn't the part of this semester. But I wanted to do that. And then the Arduino Nano IoT will be connected to my other sensor. For now, I have just taken two sensors, but I would be adapting more sensors into my program as, while showing my final product. But keeping it simple because I wanted to work with only few things so that I could have a fully functional project and then adding something more onto it. So I have this Raspberry Pi 4, and then the Arduino Nano IoT33 would be connected to my sensors. For the time being, I am going to be using RFID and the ultrasonic sensor in order to detect whether the lane is completely filled or how many numbers of objects or how many numbers of vehicles are there present on the lane, and then it will be changing the traffic light accordingly. And here I would be creating the traffic light with the help of the LEDs. And the other thing that I would be doing is creating a pedestrian creating a button for the pedestrian. If they wanted to cross, they could press that, and after 30 seconds or something, the lane would be open for them where they wanted to actually cross. So that lane would be open for the pedestrian at that particular period of time, and the vehicles of that particular lane would be having a red light. So a green light for the pedestrian and a red light for the vehicles for that, so that it is safe for them in order to cross the road and prevent many accidents. And the other thing, so it talks about the implementation tools, the Raspberry Pi 4, Arduino Nano 33 IoT, IR sensor. For time being now, I just wanted to work with the IR sensor and ultrasonic sensor. And once the project is finished at this stage, I would be changing it and adapting to more and would be open to more sensors into my project. So the sensing traffic data would be detecting the real-time application, which is the important part of our project. So we need a real-time data, like whether the vehicle is present on the lane or not. Then the dynamic system will be adjusting the time. So if this particular lane is filled and this lane is empty, I would be opening I would be turning the light green for this lane for a particular period of time. It wouldn't be like the lane is open for whatever period of time there are objects, because others will lose their mind and they won't be that patient if I create a such system. Then the efficient and safety, which I talked about, I would be ensuring that for the pedestrian, so they could press a particular button. For each lane, they will have a particular button for themselves. I'm thinking of creating 4 lanes at time being now, but I don't know what will eventually happen. So all those 4 lanes would be having a button so that they could press, and after 30 seconds, they would have the time. to cross a lane because I need to focus on the people who are in the vehicle as well as on people who are traveling by themselves without a vehicle. So let's look into the fault tolerance, which is pretty important. So first of all, sorry. First of all, like if the communication between the Raspberry Pi and Arduino Nano 33 isn't working properly due to some connection problem due to the MQTT, so I would be having two codes in my program. One would be the simple code, like which we traditionally have. The one traffic light works for a particular period of time. It shows red light for a particular period of time, then it turns green, and the other light does so and so. Then the command with the program which I wanted to generate is due to the density of the vehicles present on the lane. So it will have to program, and if the communication isn't working properly, it will switch to the traditional program so that there is no chaos between the people of different lanes. And the other thing is time recovery. Now it will be dealing with the watch time. So watch time would be dealt through the LED. I would be using an LED to show a watch time, and it will be telling like this lane is open for this particular period of time, and you have these many seconds to cross this lane and all that. So then the crash recovery, if the program crashes due to any sort of error, critical error, like there is, for example, if both the lanes have same number of vehicles, what to do in that? It will just switch on to the traditional one. So that's what I'm going to do it inside the code, like what I meant by that both the lane have same vehicle. So this lane, I have one particular lane in here, and I have this particular lane in here, this side. So this lane had same number of vehicles as this lane. They can't cross at the same simultaneously because then there will be a crash. For that situation, I'll be using the traditional code again. So this is how I'm going to be dealing with the fault. And then moving on to this next side, ensuring the long-term system and the reliability is important. That's why I am stuck with the two sensors. Firstly, I want a fully functional project with these two sensors, and then moving on to something which could be more advanced using new sensors. Now I already talked about the problem domain and the industrial challenges. I would like to read it. So the traditional traffic light system operates on the fixed timing, as we talked earlier, which can lead to an insufficient traffic flow as there is an entire lane filled with vehicles and the other one has nothing, but still the lane with no vehicle present has the green light and the other lane has the red light, which is a bit chaotic for someone who is quite hard to be at a particular place urgently. And then if this increases the congestions, the smart traffic light system addresses these challenges by using the real-time data to optimize the traffic signal timing, reducing the congestion and improving the overall efficiency. Inefficient traffic flow, fixed timing system can lead to unnecessary delay, especially during off-peak hours or when traffic pattern shifts. Increased congestion, fixed timing can result in backup and gridlock, particularly during the peak hours or the unexpected events. During the Sundays, everybody is out to be at a particular place or enjoy with their family. Then the environmental impact, congestion contributes to increasing fuel consumption. Like you need to protect the resources which are present, which are given to us. So the fuel consumption takes a toll in your pocket when you're traveling, and you see these kind of situation occurs in real life all the time. Then the safety concern, I have talked about it, like they are stressed, they keep on honking to the other drivers to make them break the rule, and they break the rule. So I wanted to make much more safer safer for everyone to travel, for the drivers and even for the pedestrians. Now let's look into the block diagram. I have just created this block diagram for the two sensors. I'll be adding on to it as I have already told it multiple number of times. So I have this ultrasonic sensor and the IR sensor connected to the Arduino Nano IoT 33. So this sensor will be giving like whether the objects are present and the number of objects are present in this lane. So this will be giving the information to the Arduino Nano 33, and then it will be giving this information to the Raspberry Pi 4 through the MQTT protocol, and then the Raspberry Pi will be storing any sort of information into this database. So I want to make a database so that if someone wanted to look into this, either the system is working properly or not, they could have the previous history recorded into the database, and then the database suggested like whether there are multiple number of people. So yes, you can turn on the LED for this particular lane, the green LED for this lane, or the ultimate say could be of a traffic police officer who has the GUI, which I'll be designing. I'm thinking of designing it on a mobile phone so that they could easily access it and change the lane accordingly. Sometimes we couldn't only rely on the machine, so I am going to give ultimate say to a human being if they wanted to work through that themselves, so they can do that, and the ultimate say would be of that traffic officer or any other responsible person at that cross section of the road. So they could manually work the LEDs through it using the GUI. So, and this again, the software architecture tells like the real-time data is taken through the sensors and the speed and their directions given it to these Arduino Nano, and then it is transferring it. That's how it is talking about the signal control, how the signals are adjusted through the Raspberry Pi, how the communication is done through the IoT, and all that. So it is highly beneficial for the smart city if you wanted to establish it in the smart city. So the optimized traffic flow would be very good for them, and it will actually reduce the congestion in that, and it is sustainable because it is reducing the carbon footprint, because that particular lane which is highly loaded with vehicles could easily travel, and they are just not wasting their fuel at that particular period of time, because it takes a lot of time to turn off and then restarting the engine and get it warm, and it actually wastes quite a number of resources. Then the safety enhances as when a particular person becomes impatient, they tend to break the rules. And the other thing, I'll be working with push buttons in order to ensure that the pedestrians can work around with this system. Then the future innovations would be, so in here I'm actually working with the ultrasonic sensor and the IR sensor, but if you know how the Google map works, it generally talks about the cellular signals on a mobile phone, and it tells that the particular place is loaded with the vehicle, so it shifts us to a different direction which has less traffic, even though that area is quite long in distance, but less traffic, so you will reach much more faster over there, and the track is much more sufficient and efficient. So that's what you can do. You can work with the mobile cellular network in order to do that. But the fault is it actually deals with the mobile phone. So if one particular vehicle has 10 mobile phones, it will say 10 vehicles. So that's what the fault would be in that. But it is quite a nice idea to work around if you wanted to do this with the Raspberry Pi, because establishing these many IR sensors on the road is highly tough task, and those sensors could get fused quite easily. And the ultrasonic sensor is quite sensitive, even though the object is far away and it seems like there aren't many objects. It still does something, it will still detect something. So these sensors are not that efficient, so you can work with the cellular network. The only fault in here is it calculates the number of phones present at that particular point of period of that particular period of time, and that's what makes it like a particular car has 10 phones, it will say 10 vehicles there. So talking about number of vehicles, and each vehicle would have multiple mobile phones if multiple people are traveling. So that it will tell that this area is congested, and that could be a problem, but there would be potentially other solution to figure out how to fix this. So that's my project pitch. Thank you for watching.